experimental probability. Our objective is to determine the experimental probability of an event, as well as use experimental probability to make predictions. Why learn this? Experimental probability can be used by manufacturers for quality control. Let's start with some vocabulary. An experiment is an activity involving chance. A trial is each repetition or observation of an experiment. An outcome is each possible result, so it's the result that you end up with. And the sample space is the set of all possible outcomes. So let's look at the experiment of rolling a number cube. The sample space is the set 1, 2, 3, 4, 5, and 6. Notice how it's in braces. The reason is to show that it's a set. If the die landed on the number 5, that would be the outcome. Let's look at the experiment of tossing a coin. The sample space is either a heads or a tails. If it landed on heads, the outcome would be heads. If it landed on tails, the outcome would be tails. How about the experiment of spinning a game spinner? In this case, you would have red, blue, green, and yellow for the sample space. And the outcome would be green. Let's look at a few more vocabulary words. An event, the outcome or set of outcomes in an experiment. A probability, the measure of how likely an event is to occur. More specifically, experimental probability is the ratio of the number of times the event occurs to the number of trials. So experimental probability equals the number of times the event occurs and the number of trials. So say you flip a coin 10 times and 4 times it ended up being a heads. So the number of times you got a heads was 4, the number of times you flipped the coin was 10. So your number of trials would be 10. A prediction is an estimate or guess about something that has not yet happened. Let's start by looking at identifying sample spaces and outcomes. Tossing 2 coins. So we're not just tossing 1 coin like in our definition here. We're tossing 2 coins. So your sample space would be heads heads, heads tails, tails heads, and tails tails. And the outcome that we happen to see over here, 1 coin landed on heads and the next on tails. So the outcome is heads tails. When spinning a game spinner, the sample space for the spinner at the right is yellow, red, blue, and green. And it landed on green, so that's the outcome. If something is impossible to happen, that means it's never going to happen. It has a probability of 0%. If something is certain to happen, meaning every single time, no matter what, you're going to have that result, that's 100%. So events with 100% probability are always going to happen. Events with a probability of 50% have the same chance of happening as not. Like flipping a coin. You have a 50% chance that it will land on heads. Something that is unlikely has a less than 50% chance of happening, but it could still happen. Something that's likely to happen has a greater than 50% chance, but it doesn't happen every single time. So let's practice estimating the likelihood of an event. So, there are 31 days in August. Well, August always has 31 days, so this event is certain. Carlos correctly guesses a number between 1 and 1,000. Is it possible for him to guess a number between 1 and 1,000? Yeah, so it's not 0, but how likely is it? Not very likely. So it's unlikely. A coin lands heads up. Well, we talked about that in the last slide. If a coin lands heads up, you have a 50% chance of it happening. So as likely as it is not to happen. Cecilia rolls a 10 on a standard number cube. Well, a standard number cube only has 6 sides, and it is generally numbered 1 through 6. So this event is impossible of happening. Let's look at finding experimental probability. An experiment consists of spinning a spinner. Use the results in the table to find the experimental probability of each event. First one states the spinner lands on blue. So how many times does the spinner land on blue? Well, that's 8 times. But how many times was the spinner spun? So 7 plus 8 plus 5 gives us 20. So 8 out of the 20 times it landed on blue. And then we can simplify this to 2/5. The spinner does not land on green. So if the spinner does not land on green, it's taking the red and the blue. So we have 7 plus 8 divided by the total of 20. In this case, we have 15 over 20, which is equivalent to 3/4. Let's look at a quality control application. A manufacturer inspects 800 light bulbs and finds that 796 of them have no defects. What is the experimental probability that a light bulb chosen at random has no defects? Well, let's start by finding the number of times the event occurs. So, for no defects, that happens 796 times out of 800. Which, as a percent, would give us 99.5%. So now we're going to use this to help us with this next piece. The manufacturer sent a shipment of 2,400 light bulbs to a retail store. Predict the number of light bulbs in the shipment that are likely to have no defects. So if 99.5% have no defects, how many out of the 2,400 are going to have no defects? Well, to do so, we're going to take our 99.5% and we're going to multiply that by our 2,400. But we need to make that into a decimal first. So the decimal equivalent of 99.5% is 995 thousandths. We're going to multiply that by 2,400. And when we do, we end up with 2,388. So, the manufacturer predicts that 2,388 light bulbs are going to have no defects. And that ends our lesson on experimental probability.